Hello, my name is Petros Georgiadis. I work as a cloud architect in Orbit Cloud Solutions, Austria, and I would like to welcome you to the webinar about GitOps practices in AWS. The purpose of this webinar is to give a brief introduction of DevOps GitOps practices and to show you that utilizing GitOps can be simple and useful also within your organization. As we commonly say, we should work smart, not hard, and this is definitely an area where this saying applies. For the agenda of today, I would like to start with a brief introduction of common tools that are being used in the GitOps, and then spend most of the time showing the demo in AWS environment and also the code itself that is used to build the environment. So for the demo, I prepared a couple of resources already in advance in AWS to save some time, and we can quickly go through them now. So it's a Roads 53 domain and certificate in Certificate Manager. There are virtual private cloud and subnet existing, integration to GitHub, and continuous integration pipeline for the demo application, and several of its versions in Elastic Container Registry repository. So let's have a look into AWS now. We can start with the domain which is registered. This is it, and I will be using this domain to create endpoints for our individual environments, dev, test, production environment. It will be created automatically as those environments are being built. Then we have the certificate that we will be using for HTTPS traffic to secure it. In container registry, there is this repository for demo application, which is a Java application. And as outcome of a CI pipeline, there will be artifacts, the Docker images that we can see 3 of them in here. And as part of the demo, I will create another one. And here is the CI pipeline to actually build the artifact from the source code. So we have integration to GitHub, and then the next step is just building the Docker image using code build. And there at some point, I will be using also these GitHub repositories to show you some other features. We have 2 repositories. One is for the application itself. It's mainly Java application. I can just quickly show you the application. It's not okay. It's a very simple Java Spring Boot application. It's just one REST controller that basically returns HTTP, HTML response, and it will take a version of its application. So we will get the version, and then we will also get the color for the application from the environment variables. I will explain this later. So this is our application as one part of the demonstration, and then there will be continuous deployment pipeline actually to deploy the environments. And as a next step, I should be deploying the continuous deployment pipeline, which is not existing as of now. So I will just trigger the deployment in order to have demonstration later on. And basically, the continuous deployment pipeline is this CDK code written in Python. I will explain more details later on, but right now I will trigger the deployment of this code. using CDK. We'll come back to confirm also that this remark creates CD pipeline to deploy demo applications. So moving on, some brief description about the Git. Git is a version control system commonly used among application developers for years now. And what is new in the GitOps is that the GitOps is trying to introduce the Git as such also to the operations to manage also not just application code, but also infrastructure deployments code and application configuration. And Git gives us certain possibilities to work on simultaneously on a common code base. So multiple teams, multiple people and teams can use common code base, and they just create a copy of the code base, modify the parts of the code base that they need. Then there is a possibility to really review those changes, and after the review, we can commit those changes and push them back to our common repository. So in our demo, we use GitHub as implementation of Git, but there are many others also being used. And if I just go back, I will confirm that I really want to deploy this pipeline, and we can review the changes in AWS environment later on. So this is a very brief description about Git as such, and one of the features of the Git, I will not have a chance to cover all of the features, but one of the important features that we will be using in this demo is the Git branching, which means that we have one master or main branch that hold the code base. Like let's say that it's a production ready code base. But we want to have a possibility to be able to modify the production, to make changes. And in order not to disturb the production, we can make a branch, a feature branch. So we make a copy of this production code, and now we have two independent copies of the same code, and we can make some changes to this feature branch. We can develop our either application or our infrastructure as a code. And we can keep deploying in this picture to the dev environment. And once we feel that it's ready for testing, we can match these changes that we are creating in the feature branch. We can match them to integration branch in our case, which is some of the test environments, and tester can go and do their test as needed. Once this part is done, we can merge the same feature branch, the changes we've done to user acceptance environment or quality assurance environments for user acceptance testing. And when we pass all of the testing, we will merge these changes that we've done here, these commits, into the master branch. And in this way, we can deploy the changes to the production system. This is also something that I will be showing during the demo, so we will come back to this picture later on. I was mentioning application code and infrastructure as a code, and also application configurations. So I would not call it a new thing, infrastructure as a code, because it's been around for many years. It's getting used quite often, especially in context with the public clouds. So it's worth it to start also paying attention to infrastructure as a code. And basically what it means is that we can define our infrastructure in the code. Commonly used languages are, for instance, Terraform, which is infrastructure as a code tool available across different platforms, starting with AWS, Azure, also on-premise clouds like Proxmox, and perhaps some others. I should not forget Google Cloud. So this is the central part, and infrastructure as a code is being developed the same way as application code, and we can use also version control system for that. In our case, it will be Git. But what is really the essence or the heart of infrastructure as a code is some automation API server. And what is beautiful, I would call it beautiful in a public clouds, is that all the changes to the infrastructure in the cloud we can do via APIs and API calls. And this is exactly where the infrastructure as a code come into place, because the tooling know how to call the APIs, and it simplifies this API management. So there's probably not much more I should be saying about infra as a code. So the summary: I define the infrastructure in the code and then use some automation engine that can translate my code into the API code. And what is also important, for instance, in Terraform, that it also stores the state of the applications being deployed to the cloud. So if I move to the next slide, in my demonstration, I'm not using Terraform, which I was mentioning before, but I'm using a cloud development kit that got produced by AWS. And the cloud development kit is infrastructure as a code language that supports 5 standard programming languages, which is TypeScript and JavaScript. Then Python, this is the one that I'm using in the demo, Java and C#. And what it actually does, it transcribes the code that we produce in these languages, and it will transcribe them into the CloudFormation templates that we can see in here, which is AWS native format, how to deploy infrastructure as a code. And this CloudFormation templates can be either in JSON format or in YAML. And for developer who knows Python, it's simpler just to use a Python programming language than using a syntax of a CloudFormation for YAML or JSON. Another big advantage of using CDK is that we can use this construct of the programming language itself, like conditions, loops, and other stuff, which is very useful because in CloudFormation and as such, doing a loops or some dynamic sequences is not that trivial. So here, really, it's a big advantage of CDK. And then this CloudFormation template is being provided to AWS CloudFormation service, which takes care of the deployment of individual resources. We can also have a look later on to the CloudFormation engine as such in AWS console. So moving on, here I would like to just briefly describe what it means continuous integration and continuous deployment pipeline, CI/CD. We've heard this term a lot of time, so let's have a look at what it actually means. So continuous integration, it actually takes the source code, builds it, does some unit tests, and then can create some artifact of the source code and of the build. And this artifact can be stored in some artifactory, or in our case, we can take as an artifact the Docker image that we have deployed in Elastic Container Registry. And once we have this artifact, I will move to the bottom picture. So here we have the artifact, and we want to do something more with this, right? Because artifact as such in some Artifactory is useless. We want to deploy it somewhere. And we want to deploy it first to the test environment. Okay, here comes the deploy. So we will deploy it to the test environment to do our testing. So this deployment to test environment can be fully automated, and also the test not just can be, but should be also automated. They are performed to see if everything works as expected. And if yes, then we have another stage, which is moving the artifact to production system. And this can be fully automated without the human intervention, but more often there is some like a human trigger which says, okay, I'm happy with the test stages, with all the stages, and I'm happy to push this artifact or to deploy this artifact to the production environment. So what is a GitOps as such in a nutshell? So let's have a look into this nice picture. In the center, we have a Git, and we have also CI/CD pipeline that work together. And in the Git, we store infrastructure as a code, so description of our infrastructure, config management, which is also very important part in the final product, and application code. Normally, when we speak about microservices, it can be tens of different small applications forming final solutions. So I would keep the application code separately in separate Git instance, Git repository. It can be all in one, but I think that it's convenient to have dedicated Git repositories for application code, and then have one common repository for infrastructure and as a code and for config management in additional Git. This is how I also structured my demonstration. That's why we have two separate repositories in a GitHub. And this Git, it should contain the source of the true. This is what I was saying when we have a master branch, that it contains the declarative code, how our environment, our production environment, for instance, should look like. And this declaration is then processed by CI/CD pipeline, and our environment should be implementation of our source of the truth. So this is the process. Here in Git we have the source of the truth. Update to this source code will trigger CI/CD pipelines, and the pipelines run a series of tasks resulting in update of runtime environment to match the source. So really, this part should be matching, and this is the idea of GitOps. And what is the difference about the DevOps versus GitOps? In the past, we had a lot of time DevOps. It's still being used around, but now I'm introducing the GitOps. So what's the difference? In my opinion, the DevOps as such is just a philosophy that emphasizes the cooperation between development and operations teams. This is the essential part, because in the past it was so that the developers just produced the code, handed over to operations, and at this point their task was done, and it was up to operations to make it, to deploy it to different environments, and make it working. So the DevOps was promoting co-responsibility for software deployment and maintenance. In GitOps, in my opinion, it's a specific implementation of DevOps, and it emphasizes using Git as the source of the truth, as I was trying to explain in the previous slide. And it uses a declarative approach for managing infrastructures and applications. So meaning that I will describe how my environment should look like, and then I have a tooling in place that makes sure that the environment will be exactly matching my code in a Git. And here I would like to describe a few deployment strategies, because I keep talking about the deployments to the environments. And these are the strategies, blue, green, that are also a lot of time being referred and being used and are useful. So what it actually means, blue-green deployment. I have two separate environments that are deployed with different versions. The blue environment in this case is old environment, is deployed with version 1.0, and the green environment is deployed with version 1.1. Both of them are up and running. But the users can see only or can not see, can access only the environment with version 1. And in the background, I had a chance to also test that my green environment is working. I'm happy with that. And at some point, I will decide to switch the traffic from the old environment to the new environment, which is seen on the second picture, actually. So from now on, the users will be accessing the new version of my environment. And I will be intensely monitoring this green environment if everything is fine after the upgrade. And I might notice that something is not working, that something is wrong, and I need to make a rollback, and I need to make it quick. So what it means making a rollback in this scenario is to just change the traffic from green environment back to the blue environment to really have a minimal disruption for the end users. Then the question mark is what happens with some persistence layers like databases that are in the background, but there needs to be also scenarios that handle this situation. So it's very convenient to make a secure deployment of new versions. And in the case I need to make a rollback, I will make a rollback very fast. And after some period when I'm really happy with the new version and I know that it's stable and operational as I need, I can just shut down this blue environment to save the cost and not to have old version of the environment running that I no longer need. So this is in a short blue-green deployment. And now there is another strategy which is kind of similar but not the same. It's a canary deployment. I no longer have them blue-green, even though I could have it. But what is different now, I have a chance to route just a part of the traffic to the new environment. You can see now in 10%. So if I have a new features that I just want to test how they will be utilized by user, and if it's something that I should roll out completely, I can really say like 10% of the traffic will be going to the new version, and I can monitor how it behaves, how satisfied are the user with this new feature. And if I see that it's really welcome by the user and it's useful, then again, I will route all of the traffic like 100% to the new version, and I can shut down the old one. So this is the deployment strategy for canary deployment. And now we are coming actually to our application, to our demo application. So I think it is a good time to to go back to my AWS environment and to see how the deployment went, and I hope that everything is okay by now. So let's have a look here. It looks good that the CI continuous deployment stack got deployed. So let's first have a look into there. I will go to code pipelines. Actually, this is the tool that I'm using for deployment of the continuous deployment pipelines. And we can see that I have three pipelines deployed for three environments. And why I have three environments, you might ask why I have three environments when I deployed just one stack. And this is what I would like to explain in the configuration code that I have for this pipeline. So if I go to the config, I have this JSON file, which is just one JSON file, but it's for demo purposes. I think that it's sufficient. In normal environments, you would have probably separate configuration for different environments, but we can just quickly have a look in here what we have. So we can see that we have description of our integration to GitHub. Here's the ECR repository with the versions of the application that I was mentioning. This is Route 53 zone. Here is a reference to the certificate and certificate manager. This is common task that I was showing to you in the console itself. But here are the environments actually. I have three CI/CD pipelines in here, dev, test, and prod, which is related to these JSON objects, dev, test, and prod that I have in this configuration file. If I have some other object like quality assurance in here, then for the pipeline would be deployed automatically. And you see that I have also this blue-green. I also included red, just to make it more interesting, but I have blue-green environments with some version 0.1, 0.2. And it's not just the blue-green in this case, it's actually canary because it goes 50-50, so it will be splitting evenly the traffic across these two environments, but sending nothing to the third one. And maybe it would be better if I skip this picture for a while and just go to this picture, because this is what I'm explaining right now in the config file. This is the scenario that in the development environment, which is standalone environment, I have application with the version 0.1, which is blue. Then I have a green version, which is version 0.2, and they get load balanced 50-50. And then I have this red, which is the newest version of my application, which I mark as a red, and it will not be having by default any traffic. Then I have a test environment where I'm routing all the traffic to the green environment, but I still have possibility to access blue environment. I could delete it, but I still have it. And in production, I have only the blue environment. And the magic really with this traffic split, with this percentage, it's happening on the application load balancer from the AWS. So this is what I would like to also show you where this magic is actually happening. So let's first review the deployment if everything went according to the plan, and not just the plan, but if everything went according to this configuration. So I will go back to the environments, to the CI/CD pipelines. And this pipeline, it has two steps. First step is just to deploy the resources, and the second step is to test them. So We can see that it got deployed 12 minutes ago. So let's have a look into the details, what was actually happening. Here's the execution of CDK code. This is something similar that I would see in my console. We can see it here in code build. I'm using code build to build the code. It's one of the tools, a part of this developer tools. And down there, I have the aim points, the URLs that I can access now. And I was saying that we will be using Route 53 to access our applications. And here I can see that it's in the domain that I was showing before. So let's have a look also into the domain. And now we can see all the endpoints that got deployed. And this is another very convenient thing that you can update your DNS domain just automatically, that you have new environment and you will get automatically new endpoints in your DNS, which is fantastic. Because normally DNS is being managed by certain people, not everybody has access to there. And if you deploy something new, then you can send out a request to get updated the records in the DNS, and it might take time. And here we can see that it's done instantly, which is really fantastic. So in my dev environment right now, I have version 2 and blue. What if I refresh it? First time I still have green, and now I have blue. Blue. If I make 100 refreshes, I should be getting 50-50, but it's really not in my control, and it's on decision of the application load balancer really to decide how it wants to route the traffic. But approximately it should be 50-50. But what I can see here as well is that I have an additional endpoints, which are there for my convenience. I'm primarily interested about this environment endpoint, but for some reason, especially in dev environment, I want to have the possibility to access only the blue deployment for some reason, whatever it might be. And apparently my internet is not the fastest today, not sure why. So let's start all of them and then have a look. You see that I have these endpoints that are pointing really to the individual deployment, to the blue deployment. And here I will always be getting only the blue environment. In here, I will always be getting green environment, and this is the red environment. I told you on the diagram in here that the traffic doesn't get routed to the red environment. That's why here is a solid line and here is dotted line. But I still have a possibility, thanks to application load balancer and the DNS records, I have a possibility to access the red environment if I need for any reason. And I can imagine plenty of reasons why I would like to have this environment available. So now I would like to, okay, I also might go to the next step, which is testing. I got it tested automatically in CI pipeline that it got deployed successfully, and it's just a shell script that will ping the environment and see that it gets the environment like the version as expected. Yeah. Maybe just quickly I will open this endpoint for production and for test environment, just to see that we have something in there. In production, we said that only blue is deployed, right? And in test environment, it will be only green. Okay, so the deployments, as we see in here, are responsive, but let's have a look how we achieve this. And we already checked the Amazon Route 53 DNS service. It's working. We also had a look to Amazon Elastic Container Registry, where we have 3 versions of the application. And what else I'm using in this deployment? It's quite simple, to be honest, but it's doing its stuff. And one of the essential services is application load balancer. So let's have a look to this load balancer and see how we can use it in order to get this canary deployment. So I will go to EC2 console and we'll find our load balancers. And we can see that we have 3 load balancers because we have 3 environments, and the most configuration is in dev load balancer. So if I scroll a little down, we have two listeners for 2 ports. First one is port 80 for HTTP, but there is a simple rule that it should redirect everything to HTTPS to port 443. This is what is actually happening. You might have noticed, I can show it again, that if I just take this URL and I might explicitly type HTTP. So this is just, I'm requesting HTTP traffic, not HTTPS. But you can quickly notice, how can I show it? Yeah, that it automatically became HTTPS traffic. And this is really due to this simple rule. Again, this is a feature of application load balancer by AWS, that it redirects traffic to this HTTPS listener, which is in here. And if I go into the configuration of this listener, so what we can see, the first thing that I would mention is that we have this certificate from certificate manager available. And I basically, because Amazon is recognized as certificate authority, and I don't need to buy the certificate from another company and import them to AWS, to the load balancer on a yearly basis to have HTTPS traffic. Really using certificate manager, I can rely on Amazon as certificate authority, and you can see that these certificates are valid. And what is another great feature is that if this certificate is attached to some resource in AWS, like we have it in load balancers, then it's eligible for renewals, which basically means that AWS will be renewing the certificates automatically. You see, here is valid to, I'm not sure where it is now. Usually it's for 1 year, the certificates, but I don't really have to worry about it, because when it's about to expire the certificate, then AWS in the background will replace it, and the listener also will have access to the new certificate. So this part will be working. I don't have to worry about that. And now looking about the rules, when I was saying about the magic, how the traffic is being splitted. So it's really done based on this percentage in here, in the listener rule. And you see again, 50-50 goes to blue and green environment, and nothing goes to the red environment on the default, on the main endpoint. But still, I have a possibility to define host-based routing, which is based on the requested endpoint. And in the blue case, everything goes to blue environment and so on. So really, application load balancer makes my life much easier when I want to play with the routing as I'm describing here. And another very useful service that I'm using is AWS Elastic Container Service in Fargate mode. It's a container management system for running Docker containers. And Fargate mode is saying that it's basically serverless deployment, and I don't have to care or worry about the underlying infrastructure. It will be taken care of by AWS to really have the capacity. And I'm also highlighting 3 availability zones. So basically, it will take care of deploying the resources where it has the capacity. So if one availability goes down, then the Fargate will at least try to find compute capacity to deploy the service into remaining availability zones. So a lot of automation and resiliency is just achieved by the way how AWS is designed. I will just quickly show you this Elastic Container Service as well in AWS environment. So if you just give me a second. And here it comes. We can see 3 clusters. In those clusters, we have 3 services. And in each service, if I go into there, we will have 1 task running. I could do additional magic in here, like auto scaling based on demand or based on CPU or memory capacity. But if I wanted to show you all the possibilities, we would be spending a lot of time in here. So let's try to keep it concise. So I hope that I explained this diagram, how it works. So 2 key parts: application load balancers and its features, and then Elastic Container Service, maybe 3 also. This Amazon Road 53 is very convenient in this scenario. And what do we have here now? It's actually about demonstrating how we can build a new version of the application. This is what I was promising at the beginning. So let's really go to the application code and create a new version of the application itself. Because I wanted to make my life really simple, I'm upgrading the versions in this build Gradle, and I will just increase the version in here, save the changes, and if I go version 0.4. If I just committed these changes and I need to push them, I committed locally to master, and I will push it right away from here to master without doing any review of the code, just because I want to save some time. So assuming that I'm not really following the proper process, I will push it right away into the master in the GitHub. And maybe we can have a look now into the GitHub application. Gradle build. And you can see that I have already version 04 in here, which is one step. But what we are really interested in, we are interested in CI pipeline, actually, that it should pick up the change that I've done. This is actually, it did pick up the change. And it should, or it triggered our build process. So we can just quickly have a look what is happening here. And the build is really about to start. It's starting now. And I'm using the command Gradle clean build. So basically, it will build the Java application, and then it will push it to the ECR repository. We can see actual steps, what will be done in, I hope I will find it. Build specs.yaml actually in here. These are the steps that are happening. It's just few lines, and it will build our application and push it to the repository where we need. So what do we have here? I was showing, first we get the version of the application from the build Gradle. We trigger Gradle clean build for building Java applications. Then we copy the artifact or the build, actual build, into the Docker subdirectory. And then using these commands, it's for logging into the ECR repository, building the Docker image, and then tagging it. Here is where we need the tag of the application. The version of the application is being used for final tag of this Docker image, and in the end we will push it into the ECR repository. So just a few lines of code. It's not code. A few commands, few shell commands will automatically build our artifact. So going back, let's see how far we are with the build process. Yeah, and I can actually see that it got finalized, that it got finished. And looking into the repository itself, if I just refresh now, we will see that the new version appeared just now. This is the time when I'm doing it. And I would like to bring to your attention also this vulnerability scanning. This is a feature given for free by AWS for this container registry, and it will scan your container if it contains some vulnerabilities. Unfortunately, it's not good for the demo, but let's have a look. I have a critical vulnerability in here. And we can have a look into this description of this vulnerability. These are some things that you can investigate. We should investigate, actually, if it was not a demo environment and if I was deploying this to real production environment, I would definitely need to take care of this. And I should find somewhere in here in which versions of Debian it got resolved, fixed. Yeah, we see the version where it got fixed. And what it would mean in my case, I really would have to go to Docker image Docker, yeah, Docker file, and to take care of a proper image, to upgrade the version of the image to the one that already has this vulnerability fixed. I'm using some, maybe in this version, probably it was not implemented yet. Really, I don't want to go in such detail, but for your information, you should just enable this vulnerability scan on your repositories, and maybe to have some monitoring of this, that it should never happen that you see something like this in your production environment. Okay, so this was one part that we built a new version of our application, and what we can do with this. This is the second part for continuous deployment, and it has actually two parts. One is continuous deployment pipeline, which is deployed from command line. This is what I did, but then we have infrastructure as a code for the environments itself. So that's why you can see, not in here, but this is for my deployment. We have CI/CD part, which has CDK in it, CI/CD stack. This is really just for creation of code pipeline and code build project to deploy actual environments. But the actual environments are defined in different stack, and this is maybe important. This is this CDK stack, and this contains this beauty that I was describing. For instance, application listener, some conditions. It should contain also update of the records in route 53, and you can see that I'm using a loops for automatically deploying the number of endpoints that I need as per my configuration. So it really goes through these deployments. For instance, it goes through this array, and for each object in the array, it performs some activities. I hope that you will have access to this code, and that you will have a chance to look into here for some inspiration, maybe, or if you would like to deploy it yourself. It should be in read-only mode. If it's not, you can let us know, and we will enable it for you. So yeah, this is our CDK code for individual environments. And what I wanted to do with this, yeah, maybe I also can show you this simple testing, this test script. I didn't spend time with some test automation. It would be done properly by testers, most likely. But let me just find the scripts when I was mentioning about it. Again, there are some loops that goes through this config.json, and it checks the version of this environment and calls the endpoints somewhere. Deployment URL, yeah, with this curl, I query the environment, and then I'm looking for the version, and if the version matches what is expected to be found. So this is very simple script, just for the demo. Yeah, we have one pipeline per each environment. This is what I was showing, and it started with commit to the given branches. Yeah, that's why I was saying that I will use this picture. Our master branch is used for production environment. Then for dev environment, we have dev branch, and for test environment, test branch. It's not matching this picture, but the idea is the same. So there is one permanent branch for per environment. So meaning if I wanted to add, for instance, quality assurance QA environment, I will need to create also the branch in the GitLab, and have it as a trigger for the pipeline itself. And now for the demo, review deployment, this is what we did previously, sorry. Review demo, create new app version, we did it already. Update AWS environment using GitLab pull request. And maybe what could be interesting is and these are actually the proposed steps. So we spent, I'm maybe thinking on improvising, but we spent already quite some time and I don't want to get it boring. So I will follow this plan steps that we will update the configuration the way that on a production environment, 10% of traffic will go to the green environment. And for that, I will create feature branch and will then create proper pull request when I can review it. And after the merge to the master branch, we will review our deployment to see that we have green version 02 available in a production environment. So let's first create the feature branch with the command git checkout minus b, and now the name, let's call it road. Okay, I now you might notice that my branch changed to this prod version 02. And what I need to do in order really to change the configuration and to add this new environment for production environment, I need to make another entry to this array. So I will just borrow from the lines above. So if I apply this configuration, this would deploy green environment with version 2 into the prod with the weight 100. And 100 and 100, it would mean routing 50-50. And this is not what I would like to do. I would like to do routing 9 to 1, which is 90 to 10. And this is the change that I would like to apply. So let's save the change. And now I can, I've done my changes that I intended. And now I would like to apply stage changes. And what I say, prod deployment. This is commit message. We then, this is the, actually I'm updating wrong field. I should be updating this one, 10%. Okay. I will commit. I committed the changes, but I committed it locally. It's now in my local copy of Git, and publishing the branch, I will push it to my remote repository in GitHub. And if I go there, which one is it? It is this one. That I have now 4 branches. And this is my branch that I just now pushed in here. So I can see the changes that I have done just now, right? And from here, I would like to use a pull request feature and create new pull request. And it's a little different. It looks that I lost my rights to create a pull request. I cannot see now, right now. I'm not owner of this repository. It looks really that I cannot create pull requests anymore in here. So I will not be showing this part. You see, I cannot just choose. This is what I would like to able to merge. Okay. So unfortunately, I will not be able to show this part, but never mind. We can use our Git. We can match the changes in my local copy and then push it to master from there. Maybe also interesting thing to do is to have a look that even though I pushed the changes to the new branch in Git, then nothing gets triggered in the pipelines. So you see that the production pipeline didn't get triggered. It was done 44 minutes ago, and I see I need to speed it up a little. So I will do a merge into the master locally from my command line, and then push it from a local master to GitHub. Okay, and you can see that the changes appeared also in here. This is what I did previously, and I'm in the master. And now I can just git push with the command git push. I can push these changes to the GitHub. Cool, it happened. And at this time, this pipeline should get triggered. So let's see if it noticed already. Yeah, and it did notice that I've done changes, and you can see the commit message in here. Product deployment version 2, 10%. So this is what is going to happen now. And if I look into the details of the code build, then we will need to give it a while really to install CDK and to run CDK, and then we can review it. So in the end, hopefully we will see this deployment. And going to the next slide, here is the review. What I was showing today is that as the main part of this webinar was creating the application environment using infrastructure as a code and CI/CD pipeline. So these were the tools that we were using: AWS CDK, AWS Code Pipeline, and AWS Code Build. Then the other major services I was also showing was Application Load Balancer, Elastic Container Service, Route 53, and Amazon Certificate Manager. Created a new version of the application. This is what we did. This was version 04, so via GitHub, also Code Pipeline, Code Build, and artifact ended in Elastic Container Registry, and updated the prod environment. So I used Git feature branch. Git pull request was not working for myself, unfortunately, but maybe some other time you will see it. And in the end, we should be having the Canary deployment. So let's have a look how far we are getting with the CDK. And it's deploying a new ECS service. So maybe this would be also interesting to have a look into ECS. And here is the production cluster, and we see that we have one pending and one running task. So we have two services. The blue is the old one. It's still running. We didn't disturb this. Yeah, this is maybe important that I did the deployment without really disturbing the running environment. This is the original environment still running, and users, maybe let's go to the production. Users can still access the environment while I'm doing the deployment. And you see right now the other environment kick in. I see the version 2. Now it should be 9 to 1 refreshes, so more or less it is. And actually, this is what we wanted to achieve, that the users didn't notice that we are doing something in the background. They can still happily use the application. And once we are ready, we'll just give them something new, like here. And we are testing if the feature is fine. So we can see that the deployment succeed. We get a new endpoint here. Also, the endpoint got registered within Route 53 zone. Do we see it? Green prod. It was not there before. Now it is there. Just let's say by miracle, but it's not a miracle. It's not even a black box. We have everything described in the steps. We have everything described in this stack, how it should register the domain. So people think it is black box, but it's very transparent for everybody who wants to know how it works. So yeah, and I have a section for question answers, but since this is not online webinar, maybe you can write something and I will try to respond. Let's see. And the very last slide is that if you are still with me watching, then I think that you must be dedicated to the topic of GitOps and you are really interested. And in that case, you will try it yourself. So thank you very much for your attention, and maybe some other time in some different topic. Thank you. Bye-bye.